Hello students, how are you? I hope you are enjoying my online classes. So let us come to the topic. In last week's lecture, I discussed with you chapter 8 for class 9th, in which in two video lectures I discussed you two parts of chapter 8. In this week's lecture, we are going to revise chapter 9. In today's lecture, we will revise these four topics, that is first half of the chapter: force and motion, Newton's laws of motion, action and reaction forces, and inertia of a body. And in Tuesday's lecture, we will revise the second half. So let me give you a brief revision. First point, force and motion. तो डियर स्टूडेंट्स, आप लोगों ने चैप्टर 8 में मोशन के बारे में पढ़ा, यूनिफॉर्म और नॉन यूनिफॉर्म मोशन. हमें पता है कि जब भी हमारे को ऑब्जेक्ट को फिर व्हेन एनी ऑब्जेक्ट is to be put in state of motion from rest or is to be put in state of rest from motion, हम उसको चाहे मोशन में लाएं या हम उसको मोशन से रोकें, रेस्ट की स्टेट में लाएं, a force is required. So what is the definition of force? Let me write this for you. The definition of force: force is an external push or pull which changes the state of motion of an object or changes size or shape of an object or try to do so. So as you can see clearly, when we apply force, it can be in form of an external push or pull which changes the state of motion of an object. By changes the state of motion of an object, we cover both the points, like from rest to motion or from motion to rest, or even the change in direction part also come in, changes the state of motion. Changes the size or shape of an object. We can compress something like sponge, we can change its size. We can bend something, we can change its shape. All these things, and try to do so. Try to do so is very important because not every time when we are applying force, some object is moving or some shape is changing. If you are pushing wall and wall is not moving, it doesn't mean you are not applying force. So that's why it is very important to add try to do so. So that is your force, and force is always associated with motion, and motion, as we have discussed in chapter 8, so in chapter 9 there is no need to tell more about motion and how an object will attain some velocity in how much time with much acceleration. That will be clear after understanding Newton's laws of motions. So moving forward to the second point, that is Newton's laws of motions. We are having three laws of motion gave by Newton. The first law of motion states that if an object is in rest, it will continue to be in state of rest. If an object is in motion, it will continue to be in state of motion until unless any external force is applied. This law is also known as law of inertia. So this law is simply saying that for having change in state of motion, which we just have discussed in the definition of force, an external force is required. Let me write it for you quickly. If an object is in state of rest, it will continue to be in state of rest, or if it is in state of motion, it will continue to be in state of motion until unless any external force is applied. So meaning of first law is very clear, that for changing the state of motion of an object, which means for changing the state of motion, if object is in rest, for making it in come in motion, or if object is in motion, then for stopping it a force is required. So this law is also known as law of inertia, because when object is in rest, it wants to be in rest, it does not want to change its states. That is known as inertia of rest. If it is in motion, it wants to continue be in motion. If we are stopping it, we are changing its state of motion, and object resists its change in state of motion. That is known as inertia of motion. Similarly, we are having inertia of direction. When object is moving in circle, a continuous force is required for keeping that object in circular motion. So that is known as inertia of direction. So Newton's first law of motion also states that, also known as law of inertia, and it says that for changing the state of motion, we require a force. Okay. Next, coming to the second law of motion, which is the most important law, as second law of motion contains the definition of both first and third law of motion. Newton's second law of motion, which is also known as real law of motion. According to Newton's second law of motion, force is equal to rate of change of momentum on an object. So second law of motion is quite simple, that force is equal to rate of change of momentum of an object. Force applied on an object is, for which force which is applied on an object is equal to rate of change of momentum of that object. So what do we understand by rate of change? Rate of change of any quantity is change in that quantity divided by time taken. So in this case, rate of change of quantity is force and it is equal to change in quantity. Quantity is momentum. So change in momentum, P2 minus P1. Final momentum minus initial momentum. This is how we can calculate the change in momentum. And for having rate, we divide it by the time taken. So this is your equation for second law of motion from the definition of second law of motion. F is equal to P2 minus P1 divided by T. We can also put the value of momentum in this as mv, where v is the final velocity, minus mu, where u is the initial velocity. So mv is final momentum and mu is initial momentum, divided by time. Taking m common, I will be having v minus u divided by t. And we all know that v minus u divided by t is known as rate of change of velocity, and that is also known as acceleration. So I can write F is equal to ma. So this is also a very famous relation. F is equal to ma, very common relation, and all these relations, they are representing Newton's second law of motion. We can apply any particular relation for solving the numerical as per given variables. If momenta and time is given, use this formula. If mass, initial, final velocity and time is given, use this formula. If mass and acceleration is given, for calculating force, use this formula. So this is how you can use any formula for calculating force. So this is your Newton's second law of motion. Coming on to third law of motion, that is simplest of all, and Newton's third law of motion explains that every action has equal and opposite reaction. So we cannot have any force working on any object having any action without having an equal and opposite reaction. That is known as Newton's third law of motion. According to Newton's third law of motion, definition is quite simple, and it says every action has an equal and opposite reaction. So very simple definition, and it says like force on one object due to the second object is exactly equal and opposite force on second object due to first object. So you can write Newton's third law of motion in equation form like this, and there are so many examples of Newton's third law of motion. Like if you will suddenly push your friend or any player in a game, if any game you are playing and you push some person suddenly, then your body also goes in backward direction. If you are on a skateboard and you are in hurry to move forward, then you may slip, because due to skateboard you are not able to take the reaction from ground. If you are stepping on shore from a boat, or on bank of a river or a lake from a boat, and if you do it quickly, then you may fall because your boat will move backward. Newton's third law of motion also find its significance when you are shooting a bullet from a gun, and when you shoot the bullet, the gun moves backward and your body receives a jerk. Newton's third law of motion also find its application in, like, when a vehicle moves forward suddenly, our body moves backward. So action, reaction. So you can also explain that phenomena using Newton's first law of motion, and as first law, second law and third law of motion, they all are representing the same thing. You need to understand this concept. I hope this concept is clear to you. So Newton's third law of motion is also about action and reaction forces. So if we are moving a heavy object, if a person is moving a heavy object, then if that person is applying force on that object, then from ground he must be taking a reaction. So if F1 is the force, let us say if F1 is the force in forward direction, then F2 force must be in opposite direction. So your F1 is equal to minus F2 vectorially. So that is action and reaction pair. So Newton's third law explains we cannot have action without a reaction, or vice versa. We cannot have a reaction without having an action. Moving on to next point, let us discuss what is inertia of a body. So inertia is the tendency to maintain the state of motion, and inertia is depending on mass. Greater the inertia, greater the mass, greater the inertia. So last topic of today's lecture is inertia of a body. So what is inertia? Inertia is the measure of mass of a body. inertia is not mass. At the same point, it is very important to understand that inertia is not the mass. Inertia is depending on the mass, but inertia is not mass. Greater the mass, greater the inertia. Inertia is the tendency of a body to maintain its state. Doesn't matter whether it is of rest or motion or direction. So we are having three types of inertia, like inertia of rest. Inertia of rest states that if a body is in rest, then it will continue to be in state of rest, as we have studied in first law of motion. And for changing its state from rest to motion, we need to apply some force, and that force is required for changing its inertia because it is having inertia of rest. Similarly, we are having inertia of motion. So if a body is in motion, which is already in motion, it has some momentum, it is having inertia of motion. For stopping that body to rest, making its velocity zero, we need to apply some force in reverse direction because the body is having inertia of motion. And similarly, for keeping an object in circular motion or changing its direction, we also need to apply force that is known as inertia of direction. So you must have experience when you are sitting in a fast moving car and that car takes a turn over the highway. If the turn is sharp enough, then you feel a force which is in outward direction. If the car is turning like this, then you will experience a force in this direction. And if the car is taking turn in right direction, then you must feel force in leftward direction. So that is what your body wants to continue in the same direction. If you are moving in a circle, then at every point your body wants to move in the direction tangent to the direction of the circle, and at each and every point the direction of our body is being changed by a force which is always towards center, that is known as centripetal force. So this force is required, this centripetal force is required because direction of motion is always changing, and for changing and the tendency of a body to maintain its direction of motion is known as inertia of direction. So I hope you enjoyed this revision lecture. Tomorrow we are going to have a live discussion class on the same lecture. So if you found any doubt, then you can ask I will take your doubts tomorrow. Like always, thanks for watching. Take care. Bye bye.